Okay, this is example 3, and we have our second order non-homogeneous differential equation, right? This our f of x is right here, and the directions are to find the general solution. So let's go ahead and maybe write that down. So the goal is to find the general solution to this non-homogeneous equation. Okay, that is, I want to find my y by first finding the general solution to the homogeneous equation, and then I'm going to add it to a particular solution of the non-homogeneous equation, and that's going to give us the most general solution to our non-homogeneous equation. So remember, we have 3 steps. So step 1 is to find y sub c. Well, that's just using the characteristic polynomial or characteristic equation. So we have r squared minus 4 equals 0. And then this is, we can easily see that r is plus or minus 2. So our y sub c, right, if you want to write of x, is equal to c1 e to the r1 of x. So one of my r1s is 2 times x, plus c2 e to the negative 2x. Okay, so here's my y sub c, so I can check that off. And now I want to construct, right, this y sub p. So construct y sub p. And again, we want the same form as our f of x. So we have 2 times e to the 3x. So we have this exponential function. So we can, again, use maybe some constant times e to the 3x. So we can say let, or choose, y sub p to be, you know, a for the constant times e to the 3x. Well, if we differentiate this, right, we get 3a e to the 3x, and then differentiate this guy, we get 9a e to the 3x. Okay, so now let's substitute these yp's and its derivatives, whoops, back into original differential equation, with the non-homogeneous one, this original one. So we have y double prime minus 4y. So y double prime, well, that's this guy. So 9a e to the 3x minus 4y. So minus 4, right, and this guy is my y. So that's just a e to the 3x, and that was equal to 2e to the 3x. And our goal, again, is to try to, we want to equate coefficients. So can we combine anything? And it looks like we can, right? E to the 3x, e to the 3x. So this is really, well, let's just go ahead and write it out. 9a minus 4a, right? We're really factoring, again, e to the 3x, or combining like terms, however you want to think about it. And again, we're equating the coefficients. So we have e to the 3x on one side, e to the 3x on the other side. So that means this expression should be equal to 2, right? Or if you want to think about it, we know e to the 3x is never going to be 0, so we can technically divide both sides by e to the 3x. So again, you choose your preference. So we know that this implies 9a minus, well, 9a minus 4a. We can simplify that. That's just 5a equals 2, and then a must be 2/5. Okay, so we found our coefficient, so let's substitute it back into our y sub p that we chose, which is this guy. So y sub p equals a, well, a is 2/5, e to the 3x. So now if we put this all together, right, our goal was to find y, which is yc plus yp. And so y sub c was c1 e to the 2x plus c2 e to the negative 2x plus our new y sub p. So we have 2/5 e to the 3x. So this is our general solution to the, so again, general solution to the non-homogeneous equation. And again, no initial conditions are given, so we can't determine our C1 and C2 for our y sub c. And that's it for example 3.